Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 19, aplenty. The elves of Gear Islands are thankful for your help and send you on your way. They even have a hang glider that someone stole from the desert island. Since you're already going in that direction, it would help a lot if you would use it to get down and return to them. As you reach the bottom of the relentless avalanche of machine parts, you discover that they are already forming in a formidable heap. You don't worry though, a group of elves is already organizing the parts and they have a system. To start, each part is rated in each of 4 categories. Extremely cool looking, X. Musical, it makes noise if you hit it. Aerodynamic, A. Or shiny, Xmas. Then each part is sent through a series of workflows that will ultimately accept or reject a part. Each workflow has the name that contains a list of rules, and each rule specifies a condition and where to send the part if the condition is true. The first rule is that matches the part being considered it's applied immediately, and the part moves on to the destination described by the rule. The last rule in each workflow has no condition and always applies if reached. Consider the workflow EX bracket X larger than 10 colon 1 comma M smaller than 20 colon 2 A larger than 30 RA. These workflows are named EX and contains 4 rules. If the workflow EX were considered a specific part, it would perform the following steps in order. Rule 1. If the part X is more than 10, send the part to a workflow named 1. Rule 2. Otherwise, if the part M is less than 20, send the part to workflow named 2. Rule A larger than 30 R. Otherwise, if part A is more than 30, the part is rejected. Rule A, otherwise, and no other rules match the part, and the part is immediately accepted. If a part is sent to another workflow, it immediately switches to start over at that workflow instead and never returns. If the part is accepted, A, sent to or rejected R, the part is immediately stops and no further processing. The system works, but it's not keeping up with the torrent of weird material shapes. The elves ask you to help sort a few parts and give you the list of workflows and some part ratings. So if you can help sort a few parts and give you a list of workflows and part ratings, your puzzle input, for example. The workflows are listed first, followed by the blank line and then ratings of parts. The elves would like you to sort all the parts beginning in the workflow named in. In this example, the 5 listed parts go through the workflow as follows. Ultimately, there are 3 parts accepted, adding up the XMAS rating for each of the accepted parts gives you 7,540 for the part with and adding all of the ratings, all accepted parts gives you a total of 19,114. Sort through all the parts of a given input. What do you get if you add them all together, all ratings and numbers? I think we need to have another directory here, a package day 19, and we need to have a class called part. We need to have a class called rule, and then the other ones are just hash maps with list, I guess. So a part has some integers, xmass, and we can have a part public part string line, and here we can take the pattern pattern compile, and let's say we take this one. All of these seems to be well formed. So we should be able to just do like this. A couple of digits. There we go. Find. Integer parse int m group 1, and we can have some getters. Now we have a couple of getters from this as well. Next up, we need a way to handle these rules. Still need to do continue, but we need to do a switch here. So boolean rules true, and rules false here. If rules, we do something, else list of part, do parts, and we can add new part of line. We pretty much need to have something line split on that, bracket, string array, and we need to have a map of string rule and list of rules. So there we go. So what we don't want to do now is pretty much the rule map should put another one there. We have array 0, and then we have a new rule that contains array 1 substring 0 to array 1 length -1. It's a string. That, then we should be fine here. So what we need to do now is figure out how to handle this kind of thing here. The first colon. Split. If argument split equal to minus 1, then end argument is equal to line. String end argument null. String evaluate and if we do that, if end argument is not equal to null, then we should return end argument. So that we can do first. That's the easy case if we get something that is just doesn't have a split. But if we have a split, then we need to figure out where the value is and if it's larger or smaller. And operation is -1 from the beginning. And we need to have a couple of these private, static, final. I think this could be final as well. It could also never be set. Let's see here. So this is greater or smaller. So we have two different cases here, greater or smaller. And then we could have private string variable. I think actually we can have a public int get var string here. Case or switch string case x return x, and then we can have the other statements here as well. MAS times 0. That, and I actually think we can skip this, and I think these should be lowercase as well. Like that. So now we could have an operation, we could have a variable, and we always think the variable is first. So we take the line and do a substring of, here we can return. We take a substring of the line, so 0 to 1. That is our variable. And then we do a substring of 1 to 2. This is equal to that. Then operation is equal to greater. Else operation is equal to smaller. And I actually done a couple of things now. I have first off picked out a number up here. I've split up the rules. Hopefully this is left leaning rules. Oh, my camera actually got stuck. So I split this up into 2 rules. Hopefully this is a left argument first kind of thing, so we don't have to handle the case where we get a rule within a rule. So just take the argument split and then rule split. And the first rule is in here, and then I have the false rule in the other end. And then I take this evaluate function here. If we have an end argument where we don't have any rules, just return that. Otherwise, if it's a greater operation, we check if the number is greater than the variable, return true rule or else false rule, and the same goes for the other way around. So I think we can actually debug this a bit. The workflows are listed below, followed by a blank line, then the ratings. All parts begin in the in. Okay. So we have an in argument. So we start here then and fetch all the rules. Then we take for part in parts. Rule map get in evaluate p. While true. Need to do something here. String start is in. We go start here. And we get start back. If we can get rule name. Call it rule name. So we go in and we get another one. If rule name equals to R, do something. Else if rule name is A, we will take the value and add the part value. Else we will set else we don't do anything. So here we need to break, and here we need to break, because we get a new rule name. So let's debug this and see what we get. Yeah, we need to create the value here. Return x plus m plus a plus s. Turn those. Let's debug this. Yeah, it didn't stop here, but we got the right result. Yeah, if we have the right result, and this is day 19, so we need to change that. And we can take this, put it in front here, and run it. What do we get then? Get that value, 325,000 something. Let's put that in. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. So that was part 1. We just needed to parse a bunch and then evaluate an expression. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. Let's go to part 2. Even with your help, the sorting process still isn't fast enough. One of the elves comes up with a new plan. Rather than sort parts individually through all of these workflows, maybe you can figure out in advance which combinations of ratings will be accepted or rejected. Each of the 4 ratings, XMAS, have an integer value ranging from a minimum of 1 and a maximum of 4,000. All of these possible distinct combinations of ratings. Your job is now to figure out which ones will be accepted. In the above example, there are distinct combinations of rating that will be accepted. Consider only your list of workflows. The list of parts ratings that the elves wanted to sort is no longer relevant. How many distinct combinations of ratings will be accepted by the elves workflows? I think I figured something out. So, I think we could have this kind of different part. So let's say that we have a figure out part or something like that. So let's go in here and create a fig part. So this fig part is something that has a min x of 0, a max x of 400 or 4,000, and then we have all the other ones as well. So we have M. We can also have a private string of next rule, which is null from the beginning. So we have a fig rule here, which takes a fig rule, a fig part, and pretty much just copies all of these values. There. One. String var int number. So we do a switch statement here of the variable, and if, in case, the switch statement is x, this value needs to be greater than this, then min x equals to number. X. Let's see, if this is smaller than number, let's see. Let's do a max of those two numbers. So that's something we need to do. Then we have the rule here, fig part. Fig part. P. New array list. End argument equals to a. Then we will take our new list and add fp. that. If an argument is null, we need to do something else. And if it's rejected, we do nothing. We just return new list. Like that. And here we do true rule. Evaluate FP. New list. That. And false. So we need to do another iteration of those. But we need to change the FP a bit. So here we need to check if operation is equal to greater. And true FP in this case needs to add greater. The variable and the number. And the false FP need to add smaller than number plus 1, right? And then we do those. Else. We need to do the same thing here, but we need to turn this around. The true statement needs to add the smaller. And the other one needs to add the greater minus 1, right? Another one of these while loops. Boolean working. True. While working. Fig part. Fig part. In. So how do we set next rule? Part string next rule. This next rule. Next rule. Set next rule. Must be able to set that as well. So here we do, if it's right else, FP set next rule and the argument. And we also need to have a get rule, right? Get next rule. So here, while we're working, we have a list of fig parts, FP list, new URL list, FP list, and the first fig part here for fig part FP in FP list. What do we start with here? We start with null. If rule name not null, we will do this, and all of that. And then we need to break that loop. So what happens here then? And we are back, and I was right, I had a bug. And it was pretty much here when we had operation greater, we look at the number and add that. But when we want to check anything that is smaller, we just need to decrease by 1 here. Then we get the right value down here. Seems reasonable. I'm not going to question it. And another part here is that I actually want to add up the combination. So I get 0 and then I add all the combinations in here. I can't mush them together. And let's run this with the large example and see what we get. Maybe we have solved day 19. Let's see. Run. And there was done. We got this large value. Let's skip over here, put it in and see. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So what did we do in part 2 then on day 19? Well, first off, we needed to have these rules. So we put the rules into a rule map where we had the rule and the string that the name of the rule. And then we had this part list that is used in part 1. And if we have a blank, then we are not looking at rules anymore. We are looking at the actual parts. So in part 1, that is interesting. And in the rule map, we just add all the rules and then we add parts in the part list. So the first round up here, we went through all the rules until we found something that was accepted and we added that value. And we started at rule in up here. But in the second case, we needed to find all the combinations. So we had this figuring out part here, which is pretty much just having the upper and lower bounds of these. We have the next rule that we need to look into. We could create fig parts by just adding a next rule. And we could also create fig parts by putting in all the numbers for the different parts. So we just copied pretty much a fig part to another one. And then we could set and get the actual rule. We could add this as a greater rule. So if this variable has a number that is greater than something, we will put this in here. And if the value is an x, we will take the max value of the min x and the number. So we will get the bounds there. The same goes for if it's smaller, then we will get the min value of the max. So we will decrease that one. And then we have this get combinations, which is pretty much taking the difference between min and max and multiplying all of those and returning as a combination. So what we did down here then is that we created this first fig part, which is the in parameter. We put that into our fig parts list. And then we set this boolean that we're working. And while we are working, we run this, where we create a new list for all the fig parts we will find. We go through all the fig parts of the old list and get the rule name. If the rule name is null, then we know that this fig part is an accepted part. It's not a rejected part, and it's not something that we need to look into more. So we will put that into the new list. But if we continue working here, we actually have a new rule name. So we will get that rule from the rule map and evaluate that with this current fig part. And we'll get a new list back here. And this new list we will set in and then continue working with it. And this evaluate function here, it takes in a fig part. And if the end argument is null, so we can't go any further here, then we will check if the operation is greater, and in that case we will create a true and a false fig part, and in the true case we will add greater, and in the false part we will add smaller, and then we will evaluate those as well. And in the other case, if it's smaller, we need to decrease the number by 1, but we add the true part as smaller and the false part as greater, and then we will evaluate those two lists. If the end argument is accepted, we will just add it to the list and say, fine, this is a good one. If it's rejected, we just ignore it, we do nothing. And if it's something else, we knew that is a rule that we need to handle, so we add the end argument as the next rule and to the list, and then we will return the list. This means that we will have, after all this working, an FP list that contains all the combinations that are valid, and we will start by a big int 0 here, and then go through the list, add all the combinations, and then print that out. So that was day 19. I hope that you found this interesting. I hope that you learned something today. If you did it in a completely different way, leave it, comment in the comment section down below and describe what you did. I read all the comments. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.